Right, so Assalamu alaikum everyone. Can you hear me?
Yes.
Okay, just a couple of announcements before we start. The first one is that this is going to be the last class, inshallah, of this course. And secondly, we'll be having our final exam, inshallah, final quiz, I should say, on Sunday, 4 to 4:30 p.m. as usual. We'll be dropping 2 quizzes, and hopefully that should be the end of it. We'll be uploading all the marks as well shortly on Zambil, and so that you can see your performance in all of the homeworks, the assignments, as well as the quizzes. If you have any questions, please ask. Okay, so in the last lecture, we talked about random access protocols. And we said that random access protocols are basically sets of rules, protocols, which nodes adhere to when accessing a common channel, such that you don't have any coordinated mechanism between these nodes. So for example, you don't have a common clock, or you don't have some centralized control, which is sort of giving permission to each one of the nodes to transmit in a particular designated slot, so to say. So random access means that whenever any node has data, it will attempt to transmit, or it will attempt to communicate to the other nodes or a particular node at random, hence the name random access protocols. And when a node has a packet to send, it transmits at the full channel rate. So there is no a priori coordination amongst the nodes. And what this can result is that 2 or more nodes can transmit at the same time. That is called a collision. Now, the name collision is sort of a misnomer in some sense. Collision simply means that 2 nodes are transmitting simultaneously. It's just the same as if 2 people start to talk at the same time. So their communication is going to get mixed up, garbled. And what usually happens then is that if they detect that a collision has taken place, of course, they can back off, they can stop transmitting, and then re-attempt to transmit once they listen that the channel is available. And that could be after a random amount of time, so that a collision does not definitely take place again. So these are some interesting observations. The first one is that before you transmit, you want to check and see that no one else is transmitting. Or in other words, before you speak, you listen. So that part is called carrier sense. Yes. And this part where you sort of back off or you stop transmitting once you hear a collision is called collision detection. So carrier sense multiple access is that you listen before you transmit, and you have multiple users accessing a common channel. Carrier sense multiple access with collision detection is a protocol where you listen before you transmit a frame on the common medium. If a collision is detected, then you back off. So basically, while you are transmitting, you're also sensing the channel to see that whether what you are transmitting is the same as what you are receiving. If there's a difference between the two, that means that someone else is also transmitting, and therefore you should stop transmission and back off. Then you also have a protocol called carrier sense multiple access with collision avoidance. This is particularly used in wireless networks. And the reason is simple, because in wireless networks, there's a great difference between the power at which you transmit and the received signal. So wireless is a very, very lossy medium. As the signal propagates, it attenuates to a very large degree. So it's basically an R4 attenuation, which means that as you per distance, I mean, the rate of attenuation is a power of 4. So the received signal is much, much, much smaller in terms of magnitude than the transmitted signal. So that means that when you are transmitting, the station itself cannot receive at the same time. So otherwise, its electronics would get basically fried, because the transmitted signal is of a much larger power. So there you would want to have a protocol which does not sense the channel while transmitting, but instead it tries to avoid collisions in the first place by sensing the channel. If the channel is free, no one else is using it, then it transmits the entire frame, and then it has mechanisms built in to avoid collisions. Now, these mechanisms are especially valid where you have sort of in the wireless mode issues such as the hidden node problem, where one station can transmit to, let's say, uh, an access point. Another station can also transmit to an access point, but they cannot both sense each other's signals. So at the access point, you would have a collision, but if each one of them, even if they were sensing, they because let's say one is on one side of the access point and its range is just up till the access point, the other is at another side and its range is just till the access point. They cannot directly communicate in any case, so they cannot listen to the other's party signal before transmission. So they would listen to the channel, and they would think that the channel is available to transmit, and they would both start transmitting simultaneously, resulting in a collision at the access point of their transmitted signals. So in that case, you typically have a protocol, a simple one, which first of all seeks permission, a clear to send signal, and then it's granted permission by the receiving station. And these are small sort of control packets which are exchanged, a clear to send, and that the receiver is ready to receive that. And once they receive that signal, only then they transmit, and that sort of avoids collisions rather than detecting collisions as they take place. But before that, you had a simpler system, Aloha and slotted Aloha, which we talked about last time. And इनके अंदर आप sense भी नहीं करते. Whenever you have something to transmit, you simply transmit it. And we talked about slotted Aloha, where you had all frames of the same size, and time is divided into slots. Each slot corresponds to the length of a frame, and nodes start to transmit when they have something to transmit at the beginning of a slot, which means that they are synchronized. And if nodes transmit in a slot, you'll have a collision. And we saw that in order for there not to be a collision, you would have to have the scenario where you transmit and nobody else transmits. So within a given frame, within a given slot, if the probability of transmitting a frame is P, and that's the same for all of the nodes, then for you to be successful, you should have a scenario where you transmit and all the other n nodes do not transmit, which means that the probability of that event would be you transmitting probability P, the others in that particular slot not transmitting 1 minus P, and they are n minus 1 of these nodes. So 1 minus P to the power n minus 1. 1 is the probability that the remaining n minus 1 nodes do not transmit, multiplied by P, the probability that you transmit, is the probability of successfully transmitting in a slot. You transmit, the remaining do not transmit. And because you have n nodes, the probability that any node has a success, any node has a success. This is a particular node has a success. Any given node has a success would be n times greater. So n times that would be the probability of any node being able to transmit successfully. And one can work out that what is the probability P star that maximizes this value. That turns out to be only 37%, which means that at best you can utilize a channel for useful transmission 37% of the time. And if you did not have this slotted system, then these frames could overlap. You could have collisions at the beginning or anywhere. So because your transmissions are not synchronized to the beginning of these slots, so what then happens is that you can have a greater probability of collisions. and that results in a probability of success, which is 1/2 of the previous case, and that is about 18%, and that is the probability or the efficiency that you will have for a pure Aloha system. So, so in carrier sense, where you listen before you speak, one could take a look at the scenario. So this was a protocol, especially inspired from this radio packet protocol, and this was the Ethernet or early versions of the Ethernet protocol. And usme what you had was a shared medium, a coaxial cable, which was running through these nodes. And these nodes were laid out so that, let's say, you had a network in maybe 100-meter radius or so. So they were spatially laid out. You would have a finite propagation delay for the signal to travel from one station to the other station. So if you remember your transmission diagrams where we showed that, let's say, this node over here begins transmitting at time t naught, okay? Then as time progresses vertically downwards, okay, the signal is going to propagate. It's propagating in both directions on this shared or common channel. And इस तरह से ये signal आगे जाता जा रहा है. And at this point in time, it's going to arrive over here. At this point in time, it's going to arrive at this place over here. Now suppose that with a small delay at time t1, ये दूसरा channel भी sort of sense करता है, ये दूसरा station भी channel को sense करता है. And notice that at this point in time, the signal from this station, because of the propagation delay, has not yet reached there. So when this node senses, it's going to sense that the channel is free, it's idle. So it will begin transmission as well. अब इसका signal U चल रहा है in time as time is progressing downwards. Yeah, as time is progressing along the vertical axis over here, ये signal भी आगे propagate करता जा रहा है. और यहाँ पे जाके ये दो signals collide करेंगे और आगे ये collide करते जाएंगे इस तरीके से. And then this node will detect of the collision, क्योंकि collision यहाँ हो गया on the channel itself, but until that signal, this yellow signal here, gets to this first node over here, this node will not be able to detect that collision. Okay? So that collision at node D is going to be detected at this point in time over here. Okay? And similarly, at node B, it's going to be detected at this point over here. Okay? So that is when these stations B and D will notice that a collision has taken place. Notice D notices that collision earlier because वो signal पहले से काफी करीब पहुंच चुका है उसके, and only after a finite duration of time, a small duration of time, इसके भेजने की start करने के बाद ये detect कर लेगा. Whereas ये signal considerably ज़्यादा time लेता है, and यहाँ पे जाके at this point in time, station B will detect that a collision has taken place. And of course, they will continue to transmit signals. They will continue to transmit the entire frame. ठीक है? But गड़बड़ हो गई है, ठीक है? And जो भी receiving stations हैं, they will not be able to receive the signal properly because of two stations simultaneously transmitting and a garbled signal on the shared channel. ठीक है? So इस केस में CSMA में collisions को आप detect नहीं कर रहे, आपने sense किया, it was idle at T0, so B starts transmitting, it keeps on transmitting the entire frame. D sensed at T1, the channel was free because at this point in time, B signal has not arrived here at D, it arrives subsequently. It senses that the channel is free, ये भी पूरा frame भेजना शुरू कर देगा, but frames will collide and transmission will not be successful, right? So in collision detection, what happens is that you will, while transmitting, first you will sense the medium, that is carrier sense. If it's free, you will transmit. If it's idle, you will transmit. But while you are transmitting, you will also keep sensing the channel. And if you notice the collision, if you detect the collision, then you will stop the transmission. ठीक है? And because of that, पूरा पैकेट जो कि आप वैसे भी जाया होगा, collision शुरू हो गए, you will abort the transmission, and that will reduce channel wastage and will result in greater efficiency. ठीक है? So whichever station detects the collision, it sends out a special signal called a jamming signal, and whenever any station receives that jamming signal, वो सारे जो हैं, they'll all back off. They'll know a collision has taken place. And this is what you have in wired networks, especially those coaxial cable, Ethernet cable, 10 base, two kind of networks that you had, and उसमें ये जो है ना, its human analogy is that there's a polite conversationalist, ये सुन रहा है, before he speaks. If nobody else is speaking, he begins to talk. But if while speaking, someone else sort of jumps into the conversation, so he'll back off. So that's the human analogy of CSMA CD. It's difficult to implement in wireless, as explained just earlier, क्योंकि यहाँ पे आपके पास your received signal strength is much smaller than your local transmission. So जो आप transmit कर रहे हैं, the transmitter is of a much greater power. Received signal strength is much smaller, and you cannot actually detect a collision taking place at the transmitter. So here, basically, in CSMA CD, B starts transmitting at T0. ये signal इस तरह से दोनों साइडों पे propagate कर रहा है. And D senses the channel at T1. It's idle. It also starts transmitting. ठीक है? But at this point over here, D detects a collision because ये transmit red signal कर रहा है और yellow उसको भी साथ मिलना शुरू हो गया. So that is where it detects a collision. Similarly, station B detects a collision at this point in time. And then after a short interval of time, it sort of stops transmitting the remaining packet. D also stops transmitting the remaining packet at this point in time. But even if it stops at this time, D and C at this time, B at this time over here, that signal then still keeps on propagating. जितना उसने transmit कर लिया था, that keeps on propagating on the channel itself. And जब तक वो sort of propagation delay for the entire आपके पास medium तक वो signal गुजर नहीं जाता, उतनी देर तक that signal actually remains on the channel. Right. So any questions here? Any questions in how the signal is propagating in this sort of timing diagram, where we're showing the propagation delays as well as the transmission delays, and where exactly is the collision being detected? And this diagram में कोई question हो कि how are we representing this collision taking place and the transmission itself and the propagation delay? Any questions here? Ji, any questions? So given these spaces, distances, ठीक है, if you've given the transmission rate, if you've given the propagation delay that this channel is incurring, you could sort of make these diagrams, you could draw them. Okay, so the algorithm, the network interface card receives the datagram from the network layer. It creates the frame, header, trailer, CRC bits, and all. Okay. If the network interface card senses the channel is idle, it starts transmitting the frame. And then while transmitting, it continuously senses the channel. Okay. So before it transmits, if it senses that the channel is busy, it waits until the channel is idle and then transmits. Then while transmitting, okay, in the first case, if it transmitted the entire frame without detecting another transmission, okay, then that would be CSMA CA only. अगर ये साथ साथ detection भी कर रहा है and it detects that while it's transmitting, no one else is transmitting, and if someone else is transmitting, it stops bots by sending a jamming signal. So then that is the collision detection part. And once it detects that a collision has taken place and it stops transmitting, it aborts its transmission, then it resenses or senses this channel again after a random amount of time. Now, why random? Because if it immediately after stopping both stations, okay, collision, because collision tabhi hoga ki you have more than one node having data to transmit. So if both stations after detecting a collision immediately try to transmit again, you will definitely have a collision again. It's just like aap baat kar rahe hain and you're listening, somebody else starts speaking and both stop talking. And then you immediately after both start talking again, okay, without a random pause. So unless you have a random pause, उसमें ये होता है कि या एक या दूसरा will after a random amount of time will sense the channel and find it free and then begin transmission. If after a random amount of time the one finds that the channel is busy, one will keep waiting until the channel is free then. So ये जो back off है, where you re-sense the channel, it has to be after a random amount of time. And the way the protocol is implemented is you have a binary exponential backoff, which means that you will choose a random amount of time between a window. And that window sort of increases after every collision. So let's say that you basically had a first collision, and then you chose to have, you will choose a random amount of time between 0 and 1, because after the first collision, M will be 1, so 0 and 1 ke darmiyan aap ek random time karenge. So, and then you'll attempt again. And then you'll wait for some multiple of let's say, that many bits. So you'll choose a random value between 0 and 1, and you will attempt to, you will sense the channel and check and see कि idle है कि नहीं है. अगर दोबारा you find कि नहीं, the channel is not available, so then you will back off again. If a second collision takes place, then you will back off again and choose a random amount of time between 0 and 3. फिर collision होता है then between 0 and 7. फिर collision होता है then between 0 and 15, and so on. So basically, you will exponentially increase this window of time जिसके अंदर आप एक random amount of time के बाद re-attempt करते हैं to have that transmission. ठीक है? So when you'll have a longer back off interval when there are more collisions. So some considerations are that a node can detect errors only if it receives a packet while it is transmitting. Okay? So in this diagram over here, agar aap transmission एक short time के लिए रखते हैं and signals बाद में propagate कर रहा है, ठीक है? So you can only detect a collision while you are transmitting, because you are transmitting one thing, on the channel you will sense something else. So you can only detect a collision while transmitting, because you're comparing what you're transmitting and what is on the channel, and that is different because it's being interfered by somebody else's signal. So if you transmit it for just a short duration and uske baad signal aapka is still on the wire, wo ja raha hai aage, so you will not be able to detect a collision. So you have to keep on transmitting, or the size of the frame that you transmit has to be such that जो भी आपके dimensions हैं network के propagation delay के corresponding, it should be such that your minimum frame should be large enough such that it should still be sending when you hear a distant station. Otherwise, the collision is going to go undetected. Okay. So the LAN size in terms of kitne meters ki local area network hai, and the minimum frame size that you have are related to one another. And you can clearly see this with this diagram. You suppose एक LAN है जहाँ पे आपके पास एक shared medium है इस तरह से. You have one station A at one end, you have another station at the other end. At time t naught, t is equal to 0, आप transmit करना शुरू करते हैं. And suppose that the time it takes for this signal, the propagation delay end to end is capital D. And suppose that just before D at t minus minus, ठीक है, ये station B channel को sense करता है and it senses कि जी the channel is idle because अभी ये नहीं पहुंचे, बस पहुंचने ही वाला है, ठीक है, लेकिन अभी ये सिग्नल यहाँ पे नहीं पहुंचे. So D minus minus पे आपने सेंस किया, you found out कि the channel is free, so station B भी transmit करना शुरू कर देता है, ठीक है. Now, so then what happens is that ये signal at time D यहाँ B पे पहुंच गया, and B will detect that a collision has taken place. So A starts at time t is equal to 0, B starts at time D minus minus. The collision on the channel takes place at D minus. Okay? And B is going to detect the collision when A signal gets to B, which is at time D. But A, of course, will detect that collision way later. Okay? And it will sort of figure out the collision hua hai at basically 2D minus minus, just the round trip transmission time, ठीक है, से थोड़ा सा पहले D minus minus, because ये signal यहाँ से दूसरा वाला जो है ना D minus minus पे यहाँ से चलना शुरू हुआ. So this will get there at D plus D minus minus, and that is the time that you'll detect a collision over there. So basically, this means that you should still be transmitting at this time. Okay? And only then will you detect the collision, which means that your frame must be at least D long, at least 2D long, which is twice your propagation delay, or in other words, equal to your round trip transmission time. That is how the minimum frame size that you must have in CSMA CD. Right. So any questions here? इसमें कोई चीज समझ ना आई हो कि why should it be equal to your round trip time or 2D के बराबर क्यों होना चाहिए? Any question?
Sir, why doesn't B stops when it detects the collision?
So B does stop. ठीक है, B तो let's say यहाँ पे stop हो गया. Okay, so it detects the collision right here, and maybe straight after, after a few microseconds, it stops transmission. But even if it stops right here, ठीक है, that signal will still keep that will still take a finite time, capital D, to actually reach to the other side. ठीक है. So if you detect and stop transmission even earlier over here, this is only sort of a diagram to sort of show कि अच्छा जी आपने collision detect कर लिया यहाँ पे, and then उसके बाद within a fraction of a microsecond आपने यहाँ पे transmission रोक दी. लेकिन फिर भी ये signal यहाँ से जब आपने detect कर दिया, ये signal will take capital D to get to the other side. ठीक है. And ये हम यहाँ पे ये show कर रहे हैं कि actually you're stopping, you're not actually stopping unless you keep on transmitting. A keeps on transmitting for this entire 2D, it won't be able to detect this collision here. ठीक है. So the important thing is the frame size, the minimum frame size should be at least 2D, and during collision detect होगा यहाँ पे ये रोक लेगा. Okay.
Right, sir.
So in this diagram over here, आप ये ना समझे कि you're stopping transmission over here. No, you have to keep on transmitting all the way up to here in order to detect the collision. So So every data link incurs a bit error rate, and that is the probability that a single bit is in error. Now, the probability that the packet is in error is, of course, much greater than the bit error rate, right? Because a packet is going to be in error when any bit in the packet is in error. Okay? So if you have a packet which has n bits per packet, then the probability that the packet is in error is given by this expression here. How do we work this? Well, अगर एक single bit in error है, तो उसकी probability PB है. So the probability that the bit is fine is going to be 1 minus PB. This is the probability that the bit is fine. The probability that n consecutive bits are fine is this same thing here, raised to the power n. That is the probability that the packet is fine. 1 minus that is the probability that the packet is corrupted. Okay. And this, of course, limits the packet size because this can't be very large. PP, अगर ये large है, of course, then packet जितना बड़ा होगा, उतना vulnerable होगा to getting corrupted. ठीक है? So you can't have a very, very big packet. But your packet must be at least as big as 2D for the network to work so that you can detect collisions. So that these two constraints together put a limitation on the size of your local area network. That's why LANs are not bigger than 100 meters or a couple of 100 meters at max for इस तरह के जो networks थे. Because otherwise, because of the bit error rate, and because of that, you would have too many frames, a collision, so too many errors in your packet anyway. So you can't have very, very, very large packets. And so you have to limit the size of the packet. This is imposing a limit कि packet बहुत बड़ा नहीं हो सकता. Maximum size के ऊपर ये एक limit है. ठीक है? And ये जो एक minimum size के ऊपर limit है. So essentially that puts in a constraint that your LAN local area network cannot be larger than a certain size. And also the more nodes that you have, the greater the probability of collisions, and will also put a further limitation on the size of the network. So you can't have more than a few hundred nodes and a few hundred meters. That was the limitations that you had in the local area networks of that design. And ये भी है because wireless के अंदर भी exactly यही considerations है as far as the maximum packet size are concerned. So for Spotted Aloha, the probability of success is directly proportional to the chances that exactly one node transmits. For pure Aloha, the probability of success is that no other frame overlaps within this frame. And CSMA CD के अंदर ये है कि the frame time or useful time divided by the total time before the next frame that you transmit, ये सारी जो efficiencies हैं, plus these further constraints that you should have, the minimum frame size being 2D, and then whenever you have a collision, ठीक है, तो 2D ज़ाया होता है because you have to transmit that again. So in other words, if you were to work out that what is the efficiency that after a successful transmission, if W is the expected number of time slots wasted, okay? So successful transmission के लिए you are basically transmitting that in time t, and so to work out the efficiency of SMA CD, basically what you're doing is कितना time आपने successfully transmit किया over a cycle time, कितना time successfully किया plus the time that you have wasted because of all these other issues, collisions and so on. So that is successful transmission time divided by a cycle time, which is the transmission time plus the time wasted before the next successful transmission. And that is constrained by 2D multiplied by W where W is the expected number of time slots wasted. Okay. So notice that W is going to be a multiple of यानी time slot जो है ना वो it's going to be I should say it's going to be a multiple of t in terms of its actual duration, okay, because time slot आपका t ही है. So number of time slots is going to be some I should say integer multiple of that. So people have done the exact sort of calculations for this, and they worked out that ये जो efficiency है उसकी that turns out to be in this order. But Sakis and Gallagher 1991 की बहुत शानदार किताब है on working out these data transmission के ऊपर, and they worked out that this is approximately the efficiency of the CSMA-CD, 1 over 1 plus 5a. 1 is basically your slot transmission time, and a works out to be d over t, which is that ratio of your propagation delay to your transmission delay. So that's an important thing. This ratio of the propagation delay to the transmission delay is an important factor in this design. Okay, so any questions over here? So we found that the efficiency of pure Aloha was 37%, 1 over E. For slotted Aloha, it's 1 over E. For pure Aloha, it was 1 over 2E, or 18%. And for CSMA-CD, the efficiency turns out to be 1 over 1 plus 5A, where A is the ratio of the propagation delay to the transmission delay. Okay. So the next thing that we want to briefly talk about is these link layer switches. Now, before we do that, just want to mention that ये जो CSMA, CD है, and ये सारी चीजें हैं, these are a bit dated. These were the protocols that we had in the 70s. आजकल चूंकि Ethernet को आप implement करते हैं through a switch, and we'll come to that switch in a minute. यहाँ पे जो आपकी transmission है, this is half duplex. You can transmit or you can receive, but you cannot transmit and receive at the same time. आजकल switches इस्तेमाल करते हैं, and in a wired setup, you have 2 split pair cables. You have a separate cable for transmitting and receiving, so you can transmit and receive at the same time. So it's इस तरह का shared medium वाला scenario, जहाँ पे एक shared cable पड़ी हुई है between these stations, is not what is commonly used nowadays. It's hardly ever. It's not used. But this is sort of historic for development of these protocol ideas, because Aloha से ही CSMA-CD का जो Ethernet का जो protocol है, that evolved, and this protocol is such a robust and such a good protocol that yani for a good part of 40 years or so, 80s all the way through 80s, 70s Ethernet start हो गया, Xerox PARC. So 70s, 80s, 90s, 2000s, this protocol was very, very successful. And then we came to these switches, link layer switches, जहाँ पे you have a common hub, and then you have a 2 split pair cable having RJ45 connector कहते हैं इसको, जहाँ पे आपके पास 8 cables होती हैं, 4 pairs होती हैं of actually wires between here. And of these wires, actually 2 pairs are used, one for transmission and one for reception. And baki jo pairs, and they're actually over there. They're not actually utilized directly. They're used for other things, control signals, or they're idle, just to sort of. And usme, so this is the commonly used structure that you have. And here you can have sort of full duplex transmission that can take place. Now, the first thing that we'll talk about is a hub. A hub is a dumb repeater. So hub में you can think of this as a device कि आपके पास एक station ने एक packet भेजा है इसको, और इसने क्या किया कि उस पैकेट को डुप्लीकेट किया, ठीक है, and it's going to transmit that on all other outgoing links at the same rate, ठीक है. So all nodes connected to hub can collide because you have and that's why we call this a single collision domain. कोई frames की buffering नहीं होती है, and there is no CMACD at the hub, and the host network interface cards are going to then detect collisions if you had any collisions, ठीक है. अब collision कैसे होगा? Because collision इस तरह से होगा कि you sense and you start transmitting. At the same time, somebody else senses and the signal hasn't got there yet. ये भी transmit करना शुरू करेगा, and then this whatever you're transmitting here is going to get copied and broadcast to the other ones. And यहाँ पे जो आप भेज रहे हैं, this will happen over here. So therefore, potentially you have trouble. So you can think of hubs as a physical layer, layer 1 dumb repeater जो के simply उस चीज को repeat कर रहा है, and all the bits coming on one link go out on all other links at the same time. Then you have a much more smarter device, a switch or a bridge, which is a link layer device. And यहाँ पे ये क्या कर रहा है कि this device has an active role. It is storing and forwarding Ethernet frames. Storing and forwarding. First thing. Second thing, it's also examining the header, and it's looking at the link layer address or the MAC address, and it's selectively forwarding the frame to one or more outgoing links using the address in the frame header. So MAC address की basis पे ये उस frame को उस particular output port पे भेज रहा है, and it's using CSMACD. Now, as far as the host is concerned, it is transparent for the host. So the host is unaware of the presence of the switch. It is plug and play. It's self-learning in the sense that switches do not need to be configured. आप switch को connect कर लें, ठीक है? And this switch, for example, you have these stations A, B, C, and A prime, B prime, and C prime, and you have these 6 interfaces on this switch over here. So whenever it receives a frame from a particular host, it looks at the header. Header mein there is a destination MAC address and a source MAC address. Because it reads the source MAC address, it knows that interface 1 के साथ जो node connected है, उसका क्या MAC address है. That's how it learns. So it basically, by receiving frames from each one of these nodes, it learns the source MAC addresses of these particular nodes. And then when it receives a frame जिसकी destination MAC address correspond करता है to one of the nodes that it has attached to itself, जहाँ से पहले से it has learned कि वो किस particular interface के साथ connected है, तो वो selectively उसी interface पे ये forward करेगा. जब तक इसको नहीं पता कि कहाँ पे है, it's going to broadcast. ठीक है? So let's say it receives a frame, it doesn't know the destination MAC address कहाँ पे. It's going to broadcast that to everyone. कोई तो होगा. जब वो particular frame respond, वो particular node respond करेगा, तो it will learn कि अच्छा मेरे इस interface के साथ कौन सा जो है node connected है. So in this manner, it basically learns, and it is possible now that you can have an A to an A prime, a B to a B prime, C to C prime transmission taking place simultaneously, because this is effectively forwarding the packets, the frames, I should say, to the appropriate destination by having learned the MAC address. So this is a very intelligent device. It learns, and it learns on its own. So it's plug and play in that sense, and it still uses the Ethernet protocol for each of the incoming link. But of course, you have no collisions. It's full duplex, so it can transmit and receive. Each one of these stations can transmit and receive simultaneously. And वो कैसे होता है? Because the actual जो connection है ये वाला, this consists of a separate pair of cables for transmitting and receiving. So there's no trouble in terms of transmitting and receiving. You are transmitting and receiving on a separate pair of cables, and collisions don't take place because collisions के लिए you have to have a shared medium. एक ही मीडियम के ऊपर आप इकट्ठा दो नोड्स डालेंगे सिग्नल तो तब कोलिजन होगा. यहाँ पे ऐसा नहीं होगा. Okay. So the interesting thing here is that it's going to create a switch table. So the question is that how does the switch know that A prime is reachable via interface 4, or similarly B is reachable via interface 2, B prime is reachable via interface 5, and so on. Well, each switch creates a switch table, and then the entries in the switch table consist of the MAC addresses of the hosts and the interface to reach that particular host. So MAC address and the interface number, and then you'll have a time to live kind of a thing कि जी इतने time तक, typically 20 minutes तक or so, अपनी sort of cache में उस particular चीज को वो live रखता है. So that you know, okay, as long as it receives a packet, then it updates that for the next 20 minutes. It knows कि अच्छा इस interface के साथ अगर मुझे कोई packet मिला to destined for here, I'm going to forward it there. So in that sense, it looks like a routing table. That table looks like a routing table, and how an entry is created and maintained, it's something like a routing protocol in the sense that as soon as you receive a frame, you look at the frame header, and there you have the source MAC, and you basically from the source MAC you learn कि इस particular interface के साथ कौन सा node connected है. So in that sense, it is self-learning. So when a frame is received, the switch learns the location of the sender, the incoming LAN node का उसको पता चल जाता है कि ये इसके साथ क्या connected है. And it records that information as well as the interface in a switch table. So for example, A has a packet to send to A prime. So source MAC is A, the destination MAC is A prime. जब ये packet यहाँ से गुजरेगा, तो it will learn कि okay, interface 1 के साथ MAC address A connected है. And it will say कि अच्छा next 60 seconds के लिए, for example, I'll assume कि ये इधर ही है. It's not nowhere else. And इस तरह से it's going to, as soon as it gets a packet from any one of these nodes, it will learn कि इसके पीछे, इस interface के पीछे कौन सा node actually connected है. And then if it gets a packet to be transmitted to any one of those nodes, based upon the MAC address, it will know कि किस interface पे उसको forward करना है packet को. If it doesn't, it's going to broadcast that to all interfaces. So that's how it learns. So it's self-learning. Packet आया, आपने note कर लिया. इस पहले stage पे you didn't know कि ये A prime कहाँ पे है. So you're going to broadcast A prime to all of the interfaces. You're going to flood A prime to all of the interfaces. Now, as you do so, then this particular interface, when it has something to send back to A, it will respond back. And as soon as it responds back, the switch will then learn, aha, A prime is connected to interface number 4. And it will put that entry into the table. Okay? Now, it knows that A was connected to interface 1. So इस packet ने A को जाना है, so इसको सिर्फ interface 1 पे forward करना है and flood नहीं करना. इसको it has selectively learned. So it has learned that information and will selectively forward or send that frame only on interface 1. ठीक है? तो इस तरह से in a very sort of a smart, intelligent way, it learns what is connected to where. Any questions here? Any questions? इसमें कोई चीज समझ ना आई हो कि ये कैसे लर्न कैसे करता है? जी So when you put this all together, when you interconnect switches, so let's say switch 1 connects ABC, and then you have another switch S2 which connects DEF, then you have another switch S3 which connects GHI, and then these switches S1, S2, and S3 are connected together through this bigger switch S4. Okay. So then once again, the question is that how do you send something from A to G? From A to G. How does S1 know to forward the frame destined to G via S4 and S3? Well, once again, you have self-learning, which works exactly the same way as a single switch case. Okay? So when you have this hierarchy of switches, then basically in the first instance, the switching table will show switch tables and packets will S1 जो है इसको पता होगा कि जी अच्छा ये जो S2 है S3 है S4 है और इसके पीछे जो MAC एड्रेसेस हैं वो सारे के सारे जो है ना 1 के साथ कनेक्टेड है. So this thing, you can think of this, it scales, and typically for a place like LUMS, an institution, you have these switches. Typically, IST ke andar, if you go, you would see at every floor, for every lab, you have a switch which connects to all of the stations, all of the hosts within that LAN, within that lab, let's say. And ये आपके पास, this is sort of a star and hub configuration के अंदर आपके पास यहाँ पे एक switch connected है. इसी तरह एक star and hub configuration के अंदर ये दूसरी LAN, दूसरी lab के सारे nodes connected हैं, and then तीसरी lab के connected हैं, और ये labs फिर आपस में on a given floor they're connected through another switch. SSE में you have the switches for every wing. You can see them in the corridors. Then they are connected for every floor. फिर वो सारे aggregate होके एक पूरी hierarchy बनती है. And then to these switches you've got other servers connected. If you visit our data center that we have on the second floor of the library building, in the data center we have about 70 plus odd servers. Okay? So you could have the mail servers there, the web servers there, Zambil के servers वहीं पड़े हुए हैं. You also have other, ये जो LMS है, ये सारी चीजें. इसी तरह से the others क्या कहते हैं services that we have servers for all of them over there. And then to the external world, you're connected through one router. Okay? Typically one router. So to the external world, that's where you have the real IP, and internally you have this is a private network, makes up a private network, and you could have given real IPs as well internally if you had enough of them, or you could make some portion over here as a private network, and then so if these were switches over here, okay, so all of these switches would be part of one subnet, and so then of course if you want to be very, very sort of pedantic, then the way you would sort of distinguish this is that at the nodes, at the end nodes, aapke paas, you have all the layers: application, transport, network, link, and physical. In a switch, it's only physical and link layer. So a switch deals with frames. A network, of course, goes all the way up to the IP layer or the network layer. Okay? And यहाँ पे आपके पास, based upon the IP addresses, आप forwarding करते हैं. So switches versus routers may, to be very exact, switches are only up to the link layer, whereas routers work up to the network layer. This is a slight misnomer, and we'll talk about that in a minute, but this is a very good and exact definition. So switches and routers both store and forward devices हैं. Routers network layer devices हैं and examine network layer headers. Switches are link layer devices and examine link layer headers. Switches base their forwarding decisions based upon the link layer address or the MAC address or the hardware address of the destination. So routers maintain routing tables and implement routing algorithms. Switches maintain switch tables and implement filtering as well as learning algorithms. So while configuring your switches, you can have all kinds of things such as you can block certain MAC addresses. You can limit कि only एक certain MAC address के साथ ही आप connect कर पाते हैं to a particular switch port. So you can do all kinds of filtering and of this nature and so on. So they are quite sophisticated and intelligent devices. And also, if you have a network like this, if you have a bigger network like this, they implement other very interesting protocols such as making a spanning tree, which then prevents loops from taking place in this sort of network that you have of these switches. Because otherwise, what can potentially happen is that if you had loops formed, then your packets could keep on sort of circulating over here. So notice that switches are working on the link layer. So ऐसा नहीं है कि every hop कोई decrement करके वो TTL खत्म हो जाए, यानी time to live खत्म हो जाएगा and the packet will get sort of उसको आप destroy करके और एक जो है ना एक management packet आप वापस भेजेंगे. No, these are switches. They're working on the link layer. So if you could potentially have loops over here and packets could keep on circulating, frames could keep on circulating for forever. So therefore, to prevent that from happening, you have these switches, also called bridges, which learn कि जी किस port के साथ क्या क्या connected, and then they sometimes block some of these ports so that you end up with a spanning tree, preventing these loops from taking place. So any questions between switch क्या चीज है and router क्या चीज है और उसमें फर्क क्या है and how does this all sort of glue together? Now, when I say it was a misnomer, well, the reason for that is that the high-end switches that you can buy today actually do sort of routing functions. Okay? Therefore, that distinction in the vendor market between a switch and a router is not this academic definition कि अच्छा switch link layer तक ही काम करता है and router जो है वो network layer पे काम करता है. Whenever you buy a router, वो definitely network layer तक ही काम करेगा. But whenever you buy a high-end switch, you have to see कि अच्छा a high-end switch is some routers are actually also called high-end switches. So when you buy a high-end switch, though it might have a routing function inside it. So that's why ये जो distinction है switch and router की ये थोड़ी सी gray है when you actually go and buy these products. ठीक है जी. So just to recap very quickly, we've talked about in this course, broadly speaking, that how do end nodes communicate across the globe, what is packet switching, and then uske through how through packet switching end-to-end application layer, and then transport layer being the first end layer, and then hop by hop packets go across the entire globe using IP, and through different technologies एक hop आगे frames को आप कैसे भेज के you actually manage to sort of achieve global routing of these packets and global connectivity in a seamless way. And then along the way, how does DNS work, and then how do other application layer protocols work, email कैसे काम करती है, web pages कैसे काम करते हैं, browsing कैसे होती है, peer-to-peer networks कैसे काम करते हैं, and so on. So this is like a first course in that sense, and it gives a very broad introduction to the basic principles of packet switching, as well as layering. That how do you sort of break down this complex problem into layers, and each layer independently sort of functions and provides a service to the layer above. And is tarah se, you in a seamless way can achieve this global packet switched network called the internet to function correctly. And इसके अंदर जो है क्या issues हैं, क्या challenges हैं, flow control कैसे है, congestion control कैसे है, and it just gives you a broad overview of networking. So this is the first course, and there's a series of other courses that are offered here at LUMS in the networking domain. And we'd encourage you to take more of these if you found this topic interesting. And if you have any questions, please ask. Any questions? G. So overall, how did you find the course? Was it too ज़्यादा काम था, कम काम था, दरमियाना था? Any broad feedback? मुश्किल था, आसान था, बहुत ही आसान था, बहुत ही आसान था? जी?
Mostly it was good, like we were allowed to do assignments in groups, so the assignments ज़्यादा थी, but like since group work था तो it became easier. But I guess like हम सबको थोड़ा Sunday वाले quizzes हो रहा था कि हर Sunday, because generally that's the only free day we have, तो plan होते हैं तो kind of hard to manage इस तरह.
Okay, so you were busy on the Sundays and that was a bit hectic, huh?
Yeah, like to give the quiz also time भी fix हो गया था end में, तो मतलब for the test.
Probably a Sunday subah subah hoता, that would be, but then we thought कि maybe you would get up. नहीं, हमारे Sunday we were busy in that sense. Every Sunday we had to put together a quiz.
Yeah.
So neither too hard nor extremely simple. Overall, easy to manage. चले ठीक है, that's.
So also you guys like taught very well, like both of you, like it was very easy to understand looking at the lectures and like listening in class. So that was great.
So I think people who came to class did very well on the quizzes. Other people who sort of I think did not attend classes, उनकी performance थोड़ी mixed है. But overall, the book is a very, very good book. And I mean, if you got to read the book, that's a very interesting read. And so we're expecting some more programming assignments. We were also hoping to put together some more programming assignments, but especially NS3, maybe we will do that inshallah next time. But the online thing also sort of was a difficult thing for us as well. So networks, so you have this course and then you have another course which is more on the application layer, and उसमें काफी ज़्यादा वो है, it's heavier on the application layer side. Net-centric programming, net-centric computing. That's the alternative to this. I don't know if you're allowed to take both, but I think you aren't. But otherwise, then subsequently you have other courses on topics in internet research is one course which is more on the research part. But ye jo basics हैं sort of, if you understand the layers, if you understand each layer का function क्या है, ये protocols क्या करते हैं, TCP, UDP, IP, and इसके नीचे the frame layer protocols, then what happens is that it's possible to understand everything. These are the basics, because I mean we've come across many people who mix up these layers, even if they've been working in the area, exactly TCP क्या करता है, UDP क्या करता है, IP क्या करता है. They just mix them all up because there's so much terminology and it's sort of built on one on top of the other. ये सारे concepts and so if you understand these, then भले आप network security में काम करते हैं, भले आप जो है कोई distributed applications build कर रहे हैं, भले आप sort of you're working in any kind of let's say peer-to-peer or any kind of any distributed applications build कर रहे हैं, कुछ काम कर रहे हैं. So this knowledge will certainly help. And usually people who are sort of focused on programming or other things, they then take this as sort of an abstraction. Okay, they're using certain libraries to do things, but they don't really understand कि उसके नीचे what's under the hood. And especially ये जो physical layer वाली चीजें हैं, if you get some sense of what TDMA is, FDMA is, ये data rates क्या है, propagation delay as well as transmission delay, ये ऐसी चीजें हैं कि then you would know कि what are the fundamental performance limits of any system and why is it like this. So in that sense it's very, very sort of fundamental that, for example, if you're putting up a satellite network, you're going to have, no matter how much capacity you have, you can't get away from the propagation delay, and that's going to be a limiting factor in the overall performance. So propagation delay, transmission delay, these timing diagrams, they are such things that it's really sort of very, very fundamental to understand networks at a very sort of at a very sort of at a level where then you can sort of disaggregate anything. I mean, we've had interestingly PhD applicants at LUMS, and we've asked, अच्छा जी, ये propagation delay, transmission delay, timing diagrams ये बना लें, कुछ कर लें, and people have got stuck, and they've done a PhD in networks or some aspect of networks, but if you've taken this course, then of course, or if you've covered this material, then of course आपको कभी भी networks में मसला नहीं होगा. And so in that sense, it's very sort of fundamental material. We did say you'll have a Viva. I'll check up with Zartash कि इसकी logistics कैसे करनी है, क्या करनी है, and क्या duration होगी, कैसे होगी, and कब होगा. So we'll check up and see. Zartash, you there?
Ji. So I think if we decide to not have the Viva, then those marks will just get distributed across the tests, and maybe a little bit on the homeworks, mostly across the tests. But if we decide to have the Viva, we will have to, sort of, schedule the students, maybe around the same day, जब final जिस दिन है.
Final Sunday को है, right? या उस जो
नहीं, ये तो the scheduled final day, क्योंकि उस टाइम पे तो लोग फ्री होंगे.
हाँ, लेकिन तैयारी शायद खैर उसमें ये कर सकते, खैर एक thought ये है कि खैर we'll discuss that and
हाँ, we can discuss it offline and then decide के whether we want to have a.
हाँ, नहीं, we'll see, because I think if you've done okay on the tests, then I think we'll give you एक possibility है, खैर we'll discuss, we can probably scale that percentage there. If you want to get more marks, then probably you could do that through a Viva. दूसरा ये कि we could randomly say कि अच्छा 4-5 लोगों का Viva लेना चाहते हैं, just to make sure कि ये जो tests कर रहे हैं ये ठीक कर रहे हैं कि नहीं कर रहे हैं या whatever. But we will get back to you on that. So you have another.
ये चेक भी करना पड़ेगा कि I don't remember exactly, but मुझे लगता है कि शायद किसी ने ये प्याजा पे पूछा भी था. Maybe I said something that we cannot go back on now. Maybe I said कि Viva नहीं होगा. अब I don't recall. So we will check कि उसके बारे में हमने कोई announcement या कोई इस तरह की चीज जो है प्याजा पे पहले तो नहीं कही. One of the students जो अभी online है, अगर कोई if anyone recalls कि हमने वाइवा के बारे में कोई बात की है अगर पियाजा
मैंने
पे?
तो नहीं किया, I'm pretty sure I'm not saying anything about
नहीं,
it.
सर आपने कहा था कि आप लोगों ने डिसाइड नहीं किया कब
जी, मैंने क्या
अगर
कहा था?
होगा भी। सर आपने कहा था कि आप लोगों ने डिसाइड नहीं किया कि अगर होगा तो कब होगा। बस ये
अच्छा अच्छा अच्छा, चलें ठीक है, सही है। फिर देन इट कंफर्म्स विद द डिस्कशन दैट वी जस्ट हैड, सो वी विल डिसाइड इंशाल्लाह एंड वी विल लेट यू गाइस नो। और या ये इन सब लोगों का शुक्रिया जो सुबह सुबह जो है लाइव आके क्लास अटेंड करते हैं।
हाँ नहीं, I mean some we know all of these names, most of them. आज माशाल्लाह ज़्यादा बंदे आए हैं, but we've got some people who are really
उनका ये आखिरी लेक्चर है, तो आखिरी लेक्चर में कुछ खाने पीने को मिलेगा।
we wish you could have done that, but it's been a real joy actually, क्या कहते हैं, teaching this, and it's always wonderful networks के साथ है, and we just hope it would have been in person, like unfortunately वो नहीं हो सकता, and for me it's been a great distraction from the rest of my day. So I've really enjoyed coming in and doing these last lectures here. Okay, so we'll get back to you regarding the Viva very soon. देख लेते हैं कि कैसे करना है, and also we'll check and see if most of it is done, if you've got the 9 quizzes in place, programming assignments, homeworks, and सबके marks आ गए हैं, तो then
Maybe that's it. Maybe that's it.
that should be it, yeah. And अगर जिसकी 0 attendance है in all the classes, उन सब का उनका वाइवा कर सकते हैं, something to that effect. So that's a possibility. Okay. अगर कोई बिल्कुल ही classes नहीं ले रहा है and he's doing very well on the tests and quizzes, then maybe we just to reconfirm कि हाँ जी सही खुद ही कर रहा है कि we might have a viva for those students. I don't think, at least for people who've been regularly attending, we should have any concerns. Okay, so any further questions? So आप लोग सारे final year के हैं, third year के हैं, whereabouts are you in your sort of studies?
हेलो सर, अस्सलाम वालेकुम।
जी जी
सर एक क्वेश्चन है सर, पता नहीं इससे रिलेटेड है या नहीं सर। ये कि सर जो ये केबल टीवी होती है सर, इसका जो लिंक होता है सर, इसमें
हाँ
जो लिंक लेयर टेक्नोलॉजी यूज़ हो रही होती है, मतलब हमारे
हाँ
पास
जी।
जो ट्रैफिक आ रही है, चैनल्स डिफरेंट आ रहे होते हैं, तो अगर कोई एक टीवी पे चैनल चल रहा होता है तो हम वो
जी।
पीछे कैसे पता चल रहा होता है कि मतलब इसकी व्यूअरशिप ज़्यादा आ रही है सर? इस चीज़ पे सर मुझे ना थोड़ा बता दें।
उसके लिए unless you have some feedback, वो पता नहीं चलेगा. I can check up and see. I know for a fact you have the system called a protocol called DOCSIS for the cable TV, और उसमें वो DOCSIS is used जहाँ पे आपने पैकेट्स भेजने हैं across that cable network. लेकिन ये जो व्यूअरशिप वाली बात है, if your TV is simply a dumb receiver, ठीक है, तो उससे तो पता नहीं चलेगा, बिकॉज केबल टीवी में आप सारे स्टेशंस को सॉर्ट ऑफ ब्रॉडकास्ट कर रहे हैं, एंड जो बंदा जिस स्टेशन पे ट्यून करता है वो उसको व्यू कर रहा है, ठीक है. सो हाउ डू यू एक्चुअली नो कि व्यूअरशिप कितनी है अक्रॉस केबल टीवी फॉर ए पर्टिकुलर चैनल? इसका पता नहीं चलता in a system, in a simple system. I presume they use other techniques, but I'll find out and get back, because I know for a fact कि इस तरह की चीजें हैं जहाँ पे you've got software which sort of automatically at the transmitting side to actually scan and see कि कौन से advertisements कितनी duration के लिए actually लोगों ने sort of run किए हैं on the different channels. So they actually scan through all the feed and pick out the duration for the particular advertisements. लेकिन viewership का इस तरह से पता नहीं चल सकता. There's no way in a simple system where you are broadcasting कि आगे कौन क्या view कर रहा है. The transmitter would not know unless he's got some other mechanism. He's got some random survey going on, जिससे वो extrapolate करके using some statistical technique. He is trying to say कि अच्छा based on certain assumptions, based on a certain model, कि ये viewership है, वो it is not going to be exact. Zatash, would you know?
मेरा ख्याल है कि ये सर्वेस करते हैं, सर्वे सैम्पलिंग होती है और फिर उस सर्वे सैम्पलिंग से जो है वो एस्टिमेट करते हैं, इसीलिए उसके अंदर जो है ना वो बाउंड्स भी बताते हैं और जनरली जो है ना वो एस्टिमेट्स ही होते हैं। और ये सर्वेस जो है वो नॉर्मली जो है वो टीवी कंपनीज भी नहीं करती हैं, ये आउटसोर्स कर देते हैं किसी सर्वेइंग इंस्टीट्यूट्स को, और सर्वे के लिए बनी होती हैं कंपनियां, उनको जो है आउटसोर्स कर देते हैं और वो फिर लोगों के सर्वे करके मैनुअली फिर वहां से करते हैं। और ऑब्वियसली यू नो इट इज इम्पोर्टेंट टू रियलाइज के अनलेस देयर इज अ फीडबैक फ्रॉम योर टीवी डिवाइस, तो उस वक्त तक जो है ऑब्वियसली यू कैन नॉट कलेक्ट दैट डेटा ऑनलाइन, उसके लिए आपको मैनुअल सर्वे करना पड़ेगा। इट्स नॉट लाइक कि यूट्यूब के ऊपर आपने कोई वीडियो अपलोड कर दी है, उसकी व्यूअरशिप जो है वो ऑब्वियसली आपको ऑटोमेटिकली पता चल जाती है, क्योंकि
IPTV के लिए डिफरेंट है, IPTV के लिए प्रॉब्ली डिफरेंट है, बिकॉज IPTV में तो देन बिकॉज यू आर देन
फीडबैक मैकेनिज्म,
हाँ फीडबैक मैकेनिज्म अवेलेबल है IPTV में, यू विल फाइंड
जी, बट not on cable TV, not
Cable
on
TV.
yeah.
not on others. Okay, any further questions here? Okay, so thank you very much. Thank you very much. Okay.